In this video on R, we are going to learn various ways to display data. And when you hear people talk about R, one of the things a lot of people say they really like about it is its ability to do lots of different kinds of figures and graphs and the flexibility within that. So hopefully you will see that as we go through the different things you can do with displaying data and graphing in R. So the first thing we'll do, just get started, open up our basic R window, and then we're going to need to load our commander just like we did before. So go to Packages, Load Package. Remember that we only need to install the package once. We did that last time, so we don't need to do it again. Just click on Load Package, and you will get the list of all the packages you have loaded on the computer that you are at. Find R commander, RCMDR, double click, and it will open our new R commander window. And what I would suggest is that you actually do your basic R window maybe as a half screen, because when it creates the figures, it will create them in this R space and won't create them within the R commander window itself. So it's useful to have both of those fairly large on your screen so you can see both of them at the same time fairly easily. So the data that we are going to use today is the school days data from the HSauer2 package, which means if we're just using Windows, we need to go back to our basic R window, click on Packages, Load Package, and we need to load HSauer2 so that we can have access to the data sets contained within that package. Go back to R Commander, click on Data, Data and Packages, Read Data Set from an attached package. Double click HSauer2, you get all the data sets there, and we are looking for school days. Go down to the lowercase letters, and then S, double click, and then click OK. So now you can see that our data set is school days, so we're active with that. And the first thing we're going to do is a frequency distribution. And you do this by going to Statistics, Summaries, and Frequency Distributions. Pick your variable. Notice you can pick one or more. If you pick one, you'll get one frequency distribution. If you pick more, you'll get one for each. And it's only going to allow you to choose variables that are categorical or, in our language, factor variables. And so in this case, let's choose learner. Click OK. And here you get, first of all, the counts for learners. So we have 85 average learners and 69 slow learners. And then down here you get percentages. So 55.19% average, 44.81% are slow. And if we want to get a plot of this, we have to use script. So let's go ahead and open the script file for this session. So hopefully you've already downloaded that from Moodle. And then go, if you haven't, pause now and go do that and come back. But you should be able to go to Open Script File. I have it within my Lab 2 folder, and the name of the file is Displaying Data, R script. When it asks you if you want to save current log file, let's go ahead and say no. Now you've opened the script that I've created for you in advance. So here, if we'd had this open to begin with, we could have just loaded the HSauer2 package through this first command here. We want to attach the school days data set so that each time we refer to a variable, we could just use the variable name and not the name of the data set. That just makes the script easier to deal with. So let's submit that statement. And then in terms of the frequency distribution, if you look down here where it still has our script from when we used the Windows, when we got that frequency distribution, the command was actually table. Right, so the command was table. We looked at the school days data set and the variable called learner. And that's how we got this output here. So that's what this piece is here, but now we want to get the results for the variable called absent. So let's submit that. And this is a lot more difficult to deal with, right? When we had just 2 levels of our variable, it's pretty simple, but now we have lots of levels of our variable. So what this means is that there were 9 people who were never absent, 4 people who were absent once, 1 person who was absent 81 times. Right? It's just harder to figure out what these data look like as an actual frequency distribution. So we can put this into a plot, into a bar graph. And so what this is doing is it says make a bar plot of this frequency distribution. So we're nesting one command within another. So click submit again. And notice it went back to our R window. And this is a very basic figure, right? There's no axis labels. I'll show you how to do that later. But you can see, and if we look at both of these windows at the same time, that there were 9 people who were absent 0 times. You can see really easily that the highest frequency is for this bar right here, which looks to be about 5, right? 20 people were absent 5 times. And then you have this definite skew in the distribution where most people are lumped at the lower end, but then you have some people who are absent lots and lots of times. So it just makes it easier to visualize what all of these numbers look like. Okay, so keeping up with looking at the windows, now we're going to go to the graphs portion of our Commander. The first thing we're going to do is a stem and leaf. So here if you click on graphs, it gives you the options. The ones in black are the ones that you're able to do based with the kinds of information that are in the data set that's active. So let's go to stem and leaf, which is right here, stem and leaf display. It only lets us use one variable, absent. Let's click on that. And now here is our stem and leaf display. So the first thing is it tells us what the numbers mean. So 1 with a line, 2 means 12, right? So the 10 spot and the 1 spot. So our total sample size is 154. And then what this is telling us is there are 26 people that are in this particular piece of the stem and leaf. So these values are the first 5 values for 0 and the second 5 values for 0. So these are actually zeros, 1s, 2s, and 3s, right, 5 through 9. And then here we add the 10 spot. So these are 10, 11, 12, 13, 14, all the way up to 8 people fell in the lower end of the 50s, 2 53s, and a 54. And then here it's showing us that there are some outliers in the data. In fact, there are 5 outliers, the biggest of which is 81. So I want to show you some options with this. So if we go back to stem and leaf display, click on options. So parts per stem, you can either have it be automatic, that's the default, that's what we just did, and it created 2 parts per stem. You could have it do 1, and then all of the zeros would be on 1 line, so all of these numbers would be here. 2 or 5, and then style of divided stems, just stay with the default. Other options, you can trim the outliers, which will list outliers on the last row, which it's doing right here. If we unclick this, it'll just have those as part of the stem and leaf, so I'll just unclick it so you can see what that looks like. Show depths gives you these numbers over here that tells you how many data points fall within each line, so we'll uncheck that so we can see what it looks like without that. Reverse negative leaves, we don't have to worry about that because we don't have any negative leaves. So let's click OK. So notice that that first line of numbers went away and that our outliers are now just part of the histogram. All right, next let's do a bar graph. So we need to go to Graphs, Bar Graph, and then we are going to choose our variable. So let's go to School, that has 4 different options in terms of what grade level the kids are in. And our axis labels here, auto means it will give the label that is just within the data, and then we can change it. So let's see what it does for auto first, and then see how we can come back and change this. So let's click OK. So here is our bar graph, so school, with the values of F0 through F3, and then frequency. So that's pretty straightforward. Let's see what it looks like. Back to bar graph. If we change our axis labels right here. So maybe we don't want school, we don't think that's descriptive enough. Maybe when we want to say school grade level. The y-axis is good. Frequency, if we wanted to give the graph a title, we could do that here. Let's just see where that will end up. So frequency of school grade level. Okay. So now if we look at our figure, this title has changed, this one stayed the same, and it added the figure caption here. If we look in our syntax, we can see a little bit what's going on, and we'll use this more later. So just kind of as a preview, we asked for a bar plot. It's doing that frequency distribution function within that, the table function of the school days data set for the school variable. XLab is the label for the x-axis. We told it to make that school grade level. YLab we left the same as the default at frequency. And then main, so this was the label that went for the entire figure. We said make that frequency of school grade level. So you can see how you can use the menus, but then also understand what the script is doing when you're looking at the figure as well. Okay, it's also possible to do a 2-variable bar graph. So let's go up to the top of our script. So the first thing we want to do, so we're going to look at the variables of gender and race. So we'll start just with the frequency counts of that. So table, gender, comma, race, in parentheses, click submit. So now we have a 2x2 table, female and male crossed with the races of Aboriginal and non-Aboriginal. So we have 41 female Aboriginal, 43 female non-Aboriginal. You can see what that looks like pretty easily. And then if we're going to create the graph, now we want a bar plot of that frequency distribution we asked for. And then this is some of the options that we want to fill in. So beside equals true tells R how to line the bars up next to each other. We want the x-axis to be labeled race, the y-axis to be labeled frequency, and this tells it what colors to use. So we have like a 90% gray for one bar and a 60% gray for the other bar. So if we highlight these 2 lines, click submit, you can see what that looks like. So race, we've got Aboriginal, light gray and dark gray, but notice it doesn't tell us anywhere on the figure what light gray and dark gray mean. So we need to go back with our script and add a legend. So need to use the command legend. Top right tells R where to put the legend, and then we want the legend to say female and male, and we want the fill to be the first one, so female would be the gray 90, and male would be the gray 60. And this is the same order we used over here. And here I have in the note, look at the frequency table to make sure this is correct. So what we can do is just add this piece to the figure we already have. So here I just added this. And so female, the light gray bars, should be the larger number. So if we go back and cross-check that with the table we created, females are in fact the larger numbers, so we told R to do that correctly. Next, let's look at a box plot. So let's go back to our menus, graphs, and box plot, which is right here. We only have one option for a variable, which is absent, so let's just do the most basic thing and click OK. So here's our box plots. Remember this bar is our median. We have our 25th percentile, our 75th percentile, our whisker on the bottom, and the whisker on the top. And as you can see, there are several outliers in these data, which we saw earlier as well when we looked at the stem and leaf display. Okay, let's look at some options for making box plots. One thing that's nice to be able to do is to plot by group. So if we want to create different box plots for different groups, maybe we want to look at gender differently and see if females or males are absent more or less often. We click OK. So now we have one box plot for females and a separate box plot for males. The medians are a little bit different. The males have a couple of outliers, but the female is the biggest outlier there. Back to the menus, graphs, box plot. Let's look at the options. So you can identify outliers automatically, so that's automatically putting these numbers here, or with mouse. And I'll show you what that looks like. It means it won't put the number here automatically. You'll have to click on it, and then it will create the number. And here, like we saw before with the bar graph, you can change the axis labels right here within this options box. So maybe we want to change the Y to something like number of days absent. It's just more descriptive. And then I like it when my variables have capitalized first letters, so we're going to put gender there. Click OK. And now it tells us use the left mouse button to identify points and the right button to exit. Just reminding us how to do that. So we click OK there. And now, a couple of things, right? Our labels changed because we told it to use different labels. Now we have this crossbar, and our outliers don't have numbers next to them anymore. So if we want to see who this outlier is, we just put our crossbar on it and then right click, and it creates that number. So if you wanted to copy and paste this into a figure, maybe you thought it looked pretty messy to have all those numbers in there. So here you could do it without them. But it still gives you the option of finding them. And if you want to get out of this, you right click and just choose stop. And now the crossbars are gone, and if you click on the outliers, nothing happens. So it turned that function off. Another interesting thing to know is the list of colors that are available to you as you're doing these different figures, creating these different figures. Here we just use gray 90 and gray 60. That's pretty boring. If you want to get a list of all the colors that R has, just do colors, open close parenthesis, submit that. And as you can see, there's lots and lots of different things you can do, right? There's 657 different colors that you can choose from. All right, so our grays, all there are here, right, were not very interesting. It's just sort of a useful thing to know. So now I'm going to show you how to use script to create figures, and you have a lot more flexibility with script than you do with the menus. And as far as I can tell, one of the better packages for creating figures within R is called ggplot2. So if you haven't already installed this package, you need to go back to your R Commander window, click on R Console, go to Packages, Install Packages, and install ggplot2. And then once you've done that, you can either load it through the menus or just submit this line right here. And now ggplot2 is ready to go. Another thing to be aware of is, as we were creating figures before, it was just writing over the last one. If you don't want to do that, if you want to save the figures as you're going, or at least have them all somewhere for you to find, you can click on History and Recording. And now what it will do is layer them on top of each other, so you can go back and forth to different figures that you create. And you can also copy and paste the figures into a Word document as you're working on different things. So if you right-click, you can copy as a meta file or as a bitmap. A meta file is going to give you higher resolution images, so that's probably the better way to go. You can also save it as a meta file and then use it, add it into your document later. Okay, so let's go to the part of our script where we're going to start looking at this package of ggplot2. And the way this works is that it builds plots in layers. So it creates a base layer and then it adds elements on top of that. And that's what this little plus signifies, that you have to have this as part of the script or it won't work. So here's sort of the first layer, and then this basically says add another layer, now add this layer. So here what we're going to do is create a frequency bar graph, and the variable after AES, which is short for aesthetics, is the variable that's going to be on the x-axis. So if we just do this first line, ggplot, school days is the name of the data set, AES stands for aesthetics, and we want the school variable. So when we submit that first statement, it actually makes us a blank slate, essentially. It doesn't know what to do yet. We haven't given it enough information because all we have told it is what variable we're going to use, but we haven't told it what to do with that variable yet. So this next piece says create the geom, or the geometric figure, bar. So create a bar graph. So if we highlight just those through that geom bar, open close parenthesis, and click submit. All right, this is sort of the most basic figure you can get in R. Black lines and the gridded background, which I don't really like. But you can change the theme. So this is the basic default theme. And there's lots of different themes. So you can change the theme to BW, which is just black and white. So let's highlight all of these first two lines. And now the background is, you still have your grid marks, but you don't have the gray anymore. So that looks a little bit better. The next thing, we're going to create a bar graph of counts paneled by row. So we have, well, let me show you what it looks like, and then kind of we'll make sense of it. So let's copy these first two, submit. All right, so paneled by row, so we have one panel for Aboriginal and another panel for non-Aboriginal. So we're paneled by the variable of race, using the school variable and just a frequency count on the side. All right, so again, the school days data set, the aesthetic, or the variable we're going to use is school. We still are using the geom of bar, but now we added this piece to the script, facet underscore grid, and in the parentheses, race, the tilde, and a period. And this is the variable, race, that we created the different panels for. So this is the format you need to use if you want this structure where they're in rows. If you want them in columns, then the period and the tilde come before race. Just have to remember which way that goes. Click submit. Now it gives it to us in the other directions. Now we have Aboriginal on the left and non-Aboriginal on the right. I actually prefer this because I think it's easier to compare. You could easily see that F0 is about the same. F1 is definitely higher for non-Aboriginal than for Aboriginal. I just think it makes it a lot easier to compare than when they were side by side. And now here's somewhere we can show the ability to go back and forth. So if we go to history, since we're now recording, we have the options of previous and next, which you can also use your page up and your page down keys for. So if we go to previous, right, it has that saved away. If we hadn't clicked on history, that wouldn't have been an option. Now if we want to go back to where we were before, we can again go to history and click on next, or we could use the page down key. That's an easy way to navigate through the different figures and graphs that you create. Okay, next we're going to create histograms, and these are going to be for continuous variables. So for bar graphs, notice there's a little space in between the bars because these are categorical variables, right? People are in F0 or F1, they can't be somewhere in between. It's not a continuous variable. So if you want a continuous variable figure, it's better to use a histogram. So The variable of absent is a continuous variable. And now the geom we want is histogram rather than bar. So highlight these two lines, click submit. Right, and now our bars are right next to each other. In fact, they blend into each other because everything is black in this default way of looking at this. And this was just, the bin width was figured out by R. We didn't have any say in that, but oftentimes we do want to have a say in that. We want to be able to tell it what the bin width should be. So here we're designating bin width. So within this parenthesis that was just, there was nothing in it before, now we've added the option of bin width equals 5. And we're also modifying the labels. We want the x-axis to be days absent and the y-axis to be frequency. So let's see what that looks like. Highlight all three lines and click submit. Days absent, frequency, and now our bins are a little bit wider. So if we do page up, oops, click over here, do page up, here's the previous one. Bin width looks like maybe it was about 3, and I said now it's just a little bit wider because we told it to make it 5. Okay, so it's interesting to have this histogram, but maybe there's a couple of different things we want to do with it. The main goal of this next piece is to add the normal curve, but I also want to show you how to change some of the things about the color. These black lines being all black, it just looks kind of weird to me. I can't really see what's going on very well. So one thing you can do is adjust the colors. So color equals black means that the outlines, the bars will be in black, but fill equals gray, now they're going to be gray bars. We're keeping that same bin width. But notice we've added in this piece that we have to have the y-axis be density. And that's necessary in order to add this normal curve. But let's first just look at what will happen if we change the colors and then also change the axis labels to days absent and density. So if you highlight from the beginning of ggplot to before the plus sign, you can see what that does. All right, so now we have gray bars outlined in black, just easier to see what's going on. We have different labels. And now let's say you don't like these grid lines. I don't really like these grid lines. I think they look distracting. So if we go to the classic theme, click submit, it gets rid of those. We have a nice clean white background, which I just am more used to seeing. I think that's probably why I think it looks better. And now this next piece is how we add the normal curve. So we have to add a statistical function. So this is the next layer. It'll just draw the curve right on top of the figure it already created. Function equals dnorm, so that's the normal curve. Arguments, list, so the first argument, the mean, is going to be the mean of the absent variable. The standard deviation is going to be the standard deviation of the absent variable. And the color of the line we want to be black and size 1. So you can look and see what the mean really is. If you just highlight mean absent, include that last parenthesis, and click submit, down here will output 16.13636 is the mean of absent. You can do the same thing for standard deviation. You don't have to do this, but if you just want to see what they are, there's your standard deviation. So the curve it's going to plot is going to be a normal curve that has a mean of about 16 and a standard deviation of about 16. So let's see what that looks like. Let's highlight this whole section. And now it's drawn the normal curve, right? It gets cut off here because it's 0. It can't go below 0. You can't be absent less than 0 days. But then you can see how it works on the end here. So we have a lot more people who are absent on the low end, right, than fewer who are absent on the higher end. And the outliers actually don't look so bad with this normal curve. If you want to see some things we could change the color. Maybe if you want to make the normal curve really stand out, you can make it red. And let's double the size. Let's make the size 2. Let's see what that looks like. All right, so now it's very obvious where that curve is. If you really want to highlight that in a figure that you create. You could do that. Okay, next, overlaid histograms for groups. So now we're looking at the groups we're going to be looking at are the two different race groups. Again, for the variable absent in the school days data set, we're going back to our bar geome, and then for the fill, we're going to start with 0 and end at 0.7. So this is going to give us black and gray bars. So let's submit that statement. So now we have a bar that signifies everyone, but it's divided out for us by the black portion of it being the Aboriginal students and the gray portion of it being the non-Aboriginal students. If you want to have the default, you can leave off this last piece. I think the default is not terribly attractive, which is why I changed it to just black and gray, but you could change it to any other colors that you wanted. Okay, box plots. So now we're going to do a box plot for race and absent. Box plot is the geome. We're going to relabel the x-axis as race and the y label as days absent, and we're going to use that black and white theme. So highlight these 3 rows. And here you can see race, Aboriginal. Over here, non-Aboriginal on the right. We've got some outliers. Although now we don't have the option of clicking them and seeing who they are, like we did when we used the menus. You can also do error bar plots. So same variables. Now we're looking at school and absent using this black and white theme. And now we have to, I always think it's easier to see what it looks like and then explain what the script looks like. So let's go ahead and run this. Bright yellow, easy to see. So we've got school year and days absent, and now we have nice error bars within each of our school years. So what we had to do is we're still doing that basic error bar plot, right? We're telling it the geome is bar, but we have to give it we have to tell it how to create these error bars, basically. So the stat summary, so function y equals mean, geome equals bar, fill equals yellow, color equals black. So that's what created these bars for us, these bright yellow bars. It calculates the group means, sets the color of the bars, and the color of the lines. Okay, so if we just did these first 2 lines to before the plus sign. Okay, so we have just our basic yellow bars, but now we want to add those confidence limits. So CL normal is the function that we're going to use to do that, and the geome is going to be an error bar with the 0.2 and size of 1. And then this designates the width of the bars and the lines. So you can change these to make the bars look different if you don't like the way they look. Alright, so if we change, so this, you can change the width of this piece and then the size of the bar itself. So if you wanted the error bars to be more prominent, right, you can make the width 0.4. And again, you could double the size like we did with the normal curve. Alright, so now they're wider and fatter. I think that looks overbearing. I think that's too much personally. But if you really wanted to highlight that, then maybe that would be a good way to do it. I much prefer the previous, less obtrusive error bars. You can also do bar charts for 2 variables. So we're doing the absent variable, but the fill is going to be gender. So our 2 variables are absent and gender. And now the geome is bar, so it's a bar again. You need to have position equals dodge, which makes the bars for the females and the males be side by side rather than stacked on top of each other like we saw in that previous example. And then again, we're going to add the error bars. Shows it how to do that. And the error bars also have the position equals dodge. So you'll have an error bar for each gender. Changing the X labels and then the scale fill. Okay, so we have bar for female, bar for male. Each of those has the error bars. So as if you want to be able to see the bottom of this error bar, instead of this being black, it could be a different color of gray. So maybe if we want to see the bottom of the error bars, we can make this bar lighter. So we can change the 0, which was all black, to a 0.9. And then we get a light bar instead of a dark bar. Okay, so that's what you need to know for now for creating graphs and figures with R and R Commander.